So now in this video, we're going to be looking at LEDs. As you can see here, we have LEDs. And you notice right away, some are brighter than the others. The red one's really dim, yellow one's really dim. The other three are pretty bright. The red and the yellow LED, they actually have the most current flowing through them of these five. These other three have a fair amount less current flowing through them, but they're brighter. So I do have my new lamp, which is it's a reading lamp, but it's somewhat bright. I moved it away from there now, and you should probably be able to see the LEDs a little bit better. It was at its brightest setting. I'll turn the brightness down, and you can see them a little better. So, in any case, there are lighting conditions and stuff that you may factor in. So, let's turn the meter on, because you can't see my bench power supply. And you can see here that we have the probes backwards, so we have the negative voltage. And you can see here that at the rail, we have 5 volts. That's what I set the power supply to. I'm going to try to hold these two there. And watch the LEDs. Well, I put it up to 10 volts, and it gets brighter. Also, 10 volts will make the math easier. So we got 10 volts there. Now the LEDs are brighter, and the red one still is way behind, and the yellow one as well. So let's get to looking at the current going through them, and that's why I have these jumpers, so we can actually measure the current. So we have a 1 kilo ohm resistor at the positive rail. We might as well zoom in for now while I explain this. Turn the meter off. We have a 1 kilo ohm resistor at the positive rail for all of the LEDs, and then it comes to the long lead, the anode of the LED. So one lead is longer than the other. The light of the other LEDs are kind of blacking out, and we have a shorter one. So the longer one, if you have not cut them, is the anode. The shorter one is the cathode. And let's put it back, make sure we get onto the 2 right rows right there. And so the short lead, the cathode, is down 1 row, comes to a jumper, which goes to the negative rail. So that is for all of these. They're wired exactly the same. They're a diode. You have to wire them in the proper direction so that they can conduct. So now let's go back. As I said, these are all 1 kilo ohm resistors. So the red LED, let's measure the voltage across it first. So we can see the voltage that it is blocking. It's blocking 1.9 volts. And so we expect about, now that we are at 10 volts at the rail, we got 10 volts across the resistor and the LED. To make the math easy, 2 volts are across the LED, which means there's 8 volts left to go across the resistor. And it's not going to be exact, but it'll be pretty close. And there you can see we actually got the spot on 8 volts there. And so we expect the same with the yellow one. The yellow one has the same forward voltage. There you can see 2. And slightly different, you know, and you might even have slightly different voltages amongst the exact same color LED, but it will be relatively the same. So there you can see 8 volts across the 1 kilo ohm resistor. So now let's go to the green LED. So it's brighter. You may think it doesn't block as much voltage, and you can see it actually blocks more. It's blocking about 3 volts. And that is leaving at the resistor about 7 volts right there. And again, so we can keep doing that. Both blue and yellow, or blue and white, I mean, they're blocking about 3 each, both of them. So of course they're resistors. 7 volts once I get a good connection, and 7 volts. So there we go. You get the point. So, as I said, they're 1 kilo ohm resistors, and so we would have to measure that or whatever to prove that. But another thing we can do is look at the current that's going through it. So we saw basically 8 volts, 8 volts, and then 7, 7, 7 volts for those. Let's yank these jumpers and get those annoying lights out of the way. Plus, yeah, the lamp's already at its brightest setting. So this makes the math easy. They're 1 kilo ohm resistors, And it doesn't matter what the voltage actually is. We can just look at the voltage across the resistor. As long as they're 1 kilo ohm resistors, whatever voltage is across them is the current going through the resistor and everything in series with it. So that's why I took out those jumpers. Those jumpers were in series to the negative rail. Now we're going to use the meter to go in series to the negative rail. And we will measure the current, not the voltage. So it will be in milliamps. We want to make sure we're in the milliamp setting. Some meters you have to move the probe, but with this one, everything but the amp range, the red probe stays right there. So this is really straightforward. I just put this one to that jumper there, which I connect to the negative rail, and we go to the cathode of the LED, and there you can see 8 milliamps of current. And we'll get about the same with this one, the yellow LED. 8 milliamps of current. So now we're actually going to get lower current with these. We'll get 7 milliamps, 7 milliamps, and 7 milliamps. So even with slightly less current, they're a whole lot brighter. Let's go back to the 5 volts, and we'll see we have an even greater difference. So we'll still have about 2 volts across these two LEDs. It may change a little bit, might go a little bit lower as you get lower current through them. They block a little less voltage, but it's just a little less. So in any case, we'll know the voltage across the resistor because that will be how many milliamps of current it lets through. So you can see we got 3.2 milliamps of current. So we should have about 3.2 volts across the 1 kilo ohm resistor, or 1.8 volts across the LED. So just a tad bit lower than at the higher voltages. And we'll see about the same there. So 3 milliamps of current, so 3 volts across here. So about 3 volts, and we'll probably see about 2 milliamps of current with the green one. Alright, 2.5 right there. And then that one's about 2 1/4. And again, a little bit more than 2 1/4 volts. So they're quite a bit brighter though. Look at that white one, and then look at that yellow one. Quite a bit difference in brightness. So, in any case, the main takeaway is LEDs, their brightness is factored in by a number of things. So obviously the more current you put through them, the brighter they get. And you want to limit the current to 20 milliamps with indicator LEDs like these. But even then, you notice the red one was not very bright at all. The blue one was super bright. In fact, I see blue LEDs in products all the time. And like this power supply that has too much stuff on it, when I want to see how much charge I have, press the button, you got blue LEDs. And so who knows how much current they got, maybe 1 milliamp or something. They're not very bright. And I have a battery charger with a blue LED that lights up the room when you're charging it. And I've never seen that with a red LED like this. So in any case, if you want the blue LED the same brightness as the red one for a given voltage, you're going to have to use higher resistance. That is the main takeaway. So now, another thing, you don't have to memorize this. First off, the container that the LEDs came in, I'll grab that really quick. It tells you the range of voltages that you should be expecting. So I like to recommend this. Let's see if I can turn that light away. There we go. You can see that the red LEDs, we had 1.8 to about 2 volts. And then same with the yellow ones. So there you can see 1.8 to 2.2. And the blue one is close to 3, as was the green one and was the white one. So they show that on there. And that's the kit that I actually got these out of. So you can see they actually have the color to them right there. So other than the white one, which is clear. So I also have this kit, and you can see that It also has the voltages on them, and then it says 20 milliamps. So that's the maximum current they recommend to put through there. And as you could see, the blue one was extremely bright, even with only 7 milliamps of current going through it. So you don't need to go to that 20, but that is the maximum. Whereas the red one, you probably would want to go to 20 if you have a blue one with it, and then keep the blue one to, I don't know, maybe 5 or even 3 milliamps. Who knows? That's stuff you'd have to practice. Also, they got you can adjust the color on these, and then these flash. Now the problem with these is they are in clear. They're all clear, every single one of them, but they emit a different light, except for the white one. We'll do a white one. Different color lights, and these ones are frosted, so they disperse the light a little better. These kind of point the light forward a little more, and so unless you're looking directly at them, I don't really like these clear ones all that much. That's a topic for another video. But any case, I like kits like this that tell you those values. Once you worked with them a little bit, it's pretty straightforward. And so these are still open circuits. Another thing we can do, you don't need to look anything up or memorize that. We can go to the diode tester, and so it's gonna test continuity right now. So I see this a lot on meters. You'll see if I go across this jumper, it beeps, current flow through, and it's not connected to the power supply. It comes to a dead end there. So this resistor and LED come to a dead end, so we can test this, and we're not getting a beep because there's too much resistance. So that's the continuity tester. A lot of times that is at the same setting as the diode tester. So now we have the diode tester, and we can test the diode. You see it lit up a little bit, and it says about 1.8 volts for its forward voltage. So we know that is kind of low. And if we put the probes backwards, that's a way to test. Nothing's popping up, so you know you're looking at the wrong way for testing the diodes, because they only conduct in one direction. So this is looking at if it conducts and how much voltage it takes to get it to conduct. So how much voltage the LED is blocking before it starts lighting up, before it starts conducting. So there you can see 1.9, and then this one, there you can see it's brighter with the same meter, and it's taking about 2.4 volts at this low current. I'm guessing it's trying to put, or I'm guessing it's putting about a milliamp of current through there, and seeing how much voltage it takes through that. That's my guess. There you got 2.6, a little bit higher, and again 2.6, a little bit higher, and that is at low current. So in any case, LEDs and resistors, those are the two basic components you really start off learning electronics, and you see there's actually quite a bit that you can learn from them. And especially with the 1 kilo ohm resistor, you can measure the voltage across it at any time to see how much current is flowing through it. And of course that's Ohm's law. You can do that with any value resistor. It won't give you the exact milliamps if it's not a 1 kilo ohm, but you take the voltage across it in volts divided by the resistance in ohms, and that will give you the current in amps. So 1 volt across 1,000 ohms of resistance, so 1 divided by 1,000 is 1 thousandths, and 1 thousandths is the same as 1 milliamp. It takes 1,000 milliamps to equal an amp. That's why it makes the math easy with the 1 kilo ohm. But in any case, hopefully you found that all interesting. This is the basic beginner stuff you should be learning, because all these principles really apply to practically all circuits. These are semiconductors. As you could see, they take a certain voltage to start conducting. We didn't test that out, but that voltage that we saw, they're not going to light up until you you get to that voltage. And so let's just quickly wire the blue one and the red one, just really quick right there, and so that they're light up with the 5 volts at the rail. Grab this yellow jumper, and what I'm going to do, I'm going to lower the voltage, and you're going to see that the blue LED goes out before the red one because we had that forward voltage. And so turn the meter on. Good, you can still see that. So we got the 5 volts at the rail. We're going to turn it down, and when we get to a little bit below 3, you see that the blue LED went out, and the red one's pretty dim now too, but it wouldn't matter what resistor value we had. The blue one's going to go about out right now, even with the lower value resistor. Lower value resistor, the red LED would be brighter, but you can see once we get down to a little bit below 1.8, it really gets dim. It's going out too, and so that's another thing. You actually need some more voltage to keep the to get the blue LED to light up. So I'm gonna end it there. Thanks for watching, and I will see you in the next video.